Okay. Good afternoon, everybody. I'm about to give you a talk about wireless security and especially Wi-Fi traffic injection. So this is the agenda of the presentation. So we'll see quickly some .11 basics to understand how it works and how we can inject traffic on a wireless network. And then we'll see how we can attack new attacks or attack improvement using Wi-Fi traffic injection. And then what we can do against it with, nowadays standards for wireless security, WPA, WPA2, and things like this, and then conclusion. So this is a commercial slide. My company is paying for the trip, so I have to put it, so I work for them. Okay, so I think everybody in the room is aware that Wi-Fi networks are quite insecure, meaning that open networks are prone to all LAN-based layer 2 attacks, we all know. We've seen some people playing with the network here, so be careful. And that web is vulnerable. So this talk is just about it, so why do it? The thing is, people never learn. That's it. So just want to clarify some points and show you that with Wi-Fi injection, nowadays open networks and web networks just can't be used. Because traffic injection has changed quite things in Wi-Fi security field. First, it increases the number of services capabilities. If you're able to inject crap stuff, you can disconnect people, totally screw the whole wireless network. You can break web within few minutes. We'll see how you can do this. And you can attack directly station and their traffic. But still, we know this, but nowadays ISP continue to sell boxes, wireless, routers, modems with only web and nothing else, and you just can't flash it. And most commercial hotspots are based on open networks and captive portals, which is in terms of security totally suck. So for wireless basics, so .11 is an IEEE standard, so it's known commercially as Wi-Fi. Made a mistake. So it's CSMA CA based. So we listen to the traffic to see when we can edit frames. We have two modes: infrastructure that we are using in the room with an access point, or direct connection, which is called ad hoc. So it's two different modes of accessing the network, but basically the security is the same. All is relying on the association concept. So to access the network, you must be associated, meaning that you must have completed some kind of authorization towards the access point or another computer if you are using ad hoc network. So most of the things are based on the association thing, so it's quite very important. And then on the network, we have two major kind of traffic. We have data traffic, so it's what you do with the network. And aside of this, we have management traffic. So management traffic is responsible to manage the network, keep the state okay, and everything else. So everybody knows that wireless things are highly insecure because you just can't protect them for being listened or for people to send stuff in it. So they decided to put a bit of security in it. So it's called WEP. So WEP is wired equivalent privacy and not weak encryption protocol. But that's the thing it does. So it's authentication through challenge response, confidentiality with RC4. So RC4 key is based on fixed key plus 24 bytes IV. So we'll see this later. And integrity with CRC32, which is known not to be an integrity mechanism, but that's it. So about Wi-Fi injection. So Wi-Fi injection is, we have some tools for quite a few years, but they were primarily focused on injecting management traffic. So basically you need appropriate hardware, meaning especially appropriate firmware on your wireless adapter. You need an appropriate driver, and then some nifty tools to use all this and being able to inject wireless frames. So we have some tools, so you can have a look at AirJack, which is a driver for Prism 2 network adapters, which is quite cool and quite efficient. But all the library, all the tools are really focused on management traffic, because management traffic is really easy to inject. Most of the tools are based on host AP driver. So host AP driver is a driver for Prism 2 firmwares. It's indeed a very, very good driver, but Prism 2 network adapters are somehow reluctant to inject what you really want to do. As an example, if you try to inject an Ethernet broadcast frame, then it will replace your destination address with the AP address, which is quite annoying. So some good hardware. So Prism 2, all Aferos network adapters works very well, and Prism 54, which is the next generation of Prism hardware, with the appropriate driver. So for Aferos, it's a mad Wi-Fi driver, so it needs to be patched. So patch is quite easy to find. Prism 54, you have to use a development snapshot of the driver. Works quite well. In all of this, Aferos is the most easy chipset to find on the market. Prism 54 is start, so it's quite difficult to find good network adapters with it. So to inject traffic, it's quite simple when you have all this. So you load the driver and activate the adapter, meaning ifconfig the interface up, and you're going. Then you put it in monitor mode, because we just don't want to inject just Ethernet frame on a given association, but we want to inject full .11 frame with all headers and stuff. So monitor mode, appropriate channel, and then you just have to open a raw socket, basically, on the interface and play with it. But still, beyond this, you have to implement your own .11 stack. So you have to manage all the traffic that comes. And then Ethernet, IP, and find or implement libraries so you can manage to build your frames quite easily. Because building an Ethernet frame using libnet is about 50 lines of code. Building a .11 frame is double of this. So regarding the attacks. So we'll see five cases. So regarding management traffic, so management traffic is easy to cope with. All rogue AP stuff, web cracking, how to bypass captive portal authentications, So that can be pretty cool and interesting. And then attacking station associated to given networks. So management traffic is supposed to keep the state of the distribution system, so what we call the DSS, keep the state okay. So managing the association mainly, but so few things. Thing is, management traffic is totally unprotected. It's clear, it's not authenticated, you don't have integrity check on it, so you just can play with it as you like, especially spoofing management traffic. So, because management traffic is responsible to keep association, it's really easy to put denial of services on a wireless network. So you can just reject association request, station 1 to get associate, and you just answer faster than the access point. For people who are already associated, you can send disassociation frames, so telling them, oh, I'm the access point and I don't want you anymore on my access point, so go away, and they go away. You can inject fake association, so that's for APs that have a limited number of association at the same time, so when it's full, you won't connect anymore. Well, for laptops and things like PDAs, you can send frames to wake them up. So tell them, hello, wake up, I want to talk to you, and then you have a simple and cheap communication on the device. So playing with management traffic is mainly things of diagonal service. Management traffic generation is very easy. Any driver able to do master node, so to be used as an AP, is able to inject management traffic. So for my test, I played with Scapy. Scapy is a Python generation, Python network traffic generation tool. So it has a pretty good Wi-Fi layer stuff, so you can just have a look at it and have a look at nifty packet classes that are already built. So you can just make a dynamo of services with one Python one-liner. So you can see .11 packet is association, association answer, reassociation answer, deauthentication, etc. Rogue APs. So basically, if you want to build an AP from a usual Wi-Fi adapter, then you indeed need to inject frames. So you need to inject mainly traffic management. So you need to inject beacon frames. So other station can see you as an AP. Beacon frames, answer probe requests, if you want to answer them. Association requests, so you have to answer association requests so people can get association. Generate management traffic, and generate hacks from frames that are exchanged on the same wireless network. So if two associated stations want to send frames between them, then the IAP will get the frames and then duplicate them. So you have just one flag in the frame that is changing. It's 2DS from DS frame. So stations are sending 2 DS frames. So I'm sending a frame to the distribution system, and then the AP has to take the frame and copy it again, setting the from distribution system to the other station. So you have to implement this. So basically, if you're able to build an access point, you can go to any wireless network and just play the access point. and just try to get people associated to your access point instead of legitimate access point. That we call rogue APs. So rogue APs is quite a cheap attack. In fact, you just only need a wireless adapter and a IWW config by interface mod master, and then you're an AP. Recently, there was a lot of work against Wi-Fi network managers. So if you have Windows XP or Macintosh, you have just a little program that allows you to choose which wireless network you want to connect to, and it can be set and is set by default to an automatic choice. So there's been a lot of work, so you can go to see this website. It's quite interesting with a tool called Karma, which is just a tool to listen to prop requests, so see to which AP people want to connect and then fake them on the fly. So that's quite efficient, that's very easy to set up, and once people are connected to you, then you can just play with that traffic the way you want. So web cracking. So it's been quite a long time that we know that web can be cracked, but if you can't inject traffic, you just have to wait to gather big amounts of frames. So it takes, depending on the network, it takes from 1 or 2 hours to a few days or a few weeks. So web is RC4 based. So RC4 is used for SSL, for example, so quite a good stream cipher, but in the Wi-Fi context is totally inappropriate. So RC4 is XOR based. So XOR is some kind of magic computing operation. You can do about anything about it. So in the Wi-Fi context, it's prone to several attacks. So the first one is a clear text attack on the authentication mechanism. So basically, the guys who have invented this, so they said, I want to authenticate someone, so I want to verify as a good key, but I don't want to exchange the key of the network. Okay, so we'll use challenge response mechanism. So basically, they send a challenge, which is 128 bytes, not bits, bytes, which is quite long and is quite important for the following. So they send the challenge, and then the station encrypts the challenge and send it back on the wire. So if the AP can decrypt it, then the guy has a good key and is authenticated. But the thing is, RC4 is vulnerable of clear text attacks. So if you have the clear text and the cipher text, then you can grab the key. And that's it. So if you use a web network with authentication, then you're vulnerable. This leads to what we call PRGA, highly coupled attack construction. So the thing is, the key changes for each packet, because each packet uses a different initialization vector. So the key used to cipher the packet is a 24-byte initialization vector plus a fixed key, which is 104 bits or 40 bits, depending on the strength of the cipher. But using the clear text attack, you can just build a relationship between the RC4 output for a given IV, and then make a table which, in the end, will allow you to decrypt any packet on the network. So the size of this table is about 20 gigs, which is, any laptop on the market has this amount of storage. Then we had the major attack on web with this, which is a Fluor, Martin, and Chamy attack. So these guys had previously released paper on RC4 saying that using the full 512 bytes of an RC4 stream is not a good idea because you have some information in this. But in the web case, they use it. So finally, working on them, they discovered that when you use some what they call weak IDs, then you can get informations on the key that had ciphered the packet. So in the end, by grabbing about million of packets, you can just crack the key like this. So the good thing with this attack, it's not a brute force attack, it's a mathematical attack, and doubling the size of the key just doubles the time to achieve the attack. So it's really a very effective attack. And then the last one is some optimization by a guy called cedric. So cedric has found what he called solve cases. So he can just make the Fluor, Martin, and Chamy attack much faster and rely on other kinds of packets. Because when manufacturers have seen that there was weak ID, so they said, okay, we will remove all weak IDs from our driver, and then because our access point or driver does not generate weak IDs, then that's cool. But with correct optimization, that's not the case. But all these attacks needs to gather traffic. So you have to wait to have all the traffic you need to perform the attack successfully. But if we can inject traffic, then we can accelerate it. So the thing is, it's based on this. So it's a bit of math, I will go quickly, but you can read it afterward. The basic thing is RC4 and CRC are both linear things. And in fact, just playing with formulas, you can just figure out that you can just modify a given packet on the network, a ciphered packet, you don't know the key. You can modify it in a way that CRC will still be good in the end. So that these formulas, I can just take a frame and do whatever modification I want in it, and this frame will still be correct for the Wi-Fi stack. So it can be decrypted. Decrypted, the CRC will be okay, and then we'll pass the packet to other layers. So this kind of thing is used massively for two things. The first thing is Oracle-based decrypting attack. So basically, I send frames, and I look at the answers from the network. So if I get an answer, then my packet is good. If I have no answer, then it's not good. And this way, you can decrypt packet. Or you can stimulate the network to give you answers and then gathering more traffic. So an example of an Oracle attack is a correct chop-chop attack. So chop-chop is a way you take a frame and you will decrypt it. So basically, it's based on packet modification. Then you grab a packet and you will modify it byte after byte. And just reinjected your frame and looking at the network, you will deduce if your modification is good or not. And then you can deduce the value of the byte you have modified in the clear text. And then in the end, it's quite fast. In about 30 seconds, you have decrypted the whole packet. So it's quite easy. And this attack is used by a software called REcon. So REcon is quite a famous tool. REcon is a web cracking tool. It's the most efficient published for now. So basically, it will use both a recall attack, so a chop-chop attack, to try to find an ARP request who has been answered. And once you get this packet, you just re-inject it to stimulate the network. So this packet will be answered, and then you will generate traffic. And while generating traffic, you will get the amount of frames you need to perform Fleur, Martin, and Shamir attack with optimization and so on. So nowadays, with this kind of thing, you can crack a web key of 128 bytes in 10 minutes. So 10 minutes to gather traffic and crack the key. Crack the key is 1 second, but 10 minutes. So people who are telling, yeah, but I use web with .1x authentication, so the key is changing every hour, it's weak. The thing is, REcon, the current version, is not optimized. So you can add tests to reduce the amount of packet you need, and then the algorithm to explore the key space is not optimal. Sometimes it turns around and just can't find the key. But with some optimization, you can crack a key about twice or 3 times faster. So it leads to things like 5 minutes. So this is the URL of REcon. It's very impressive. So captive portals. So commercial Wi-Fi hotspot for public internet access. Most of them relies on what we call a captive portal. So captive portal is, in fact, you have a gateway of the network will allow you to get out once you've been authenticated on a website. So typically you have a web portal with a username, password, and things like this. And when you're authenticated, you're allowed to go to the internet. So this is linked to a billing system because they won't do it for free. And the thing is with all this network is the way they are tracking authorization. So once a guy is authenticated, how do they track the authorization and not having other people use it? So that we'll see. So there are basically 3 ways of, during pen test, I've seen 3 ways of tracking clients, authorized clients. The first one is MAC address based. So the guy is authenticated, you grab his MAC address, and then you will authorize any packet with given MAC address to get out. So this is basically, all these tools are based for tools that were developed for wired networks. Because on a switch wired networks, MAC spoofing is quite difficult to achieve because Ethernet switches doesn't like to have the same MAC address on 2 different ports. So they get cheeky or they deactivated ports, something like this. But on a Wi-Fi network or a wired network with hub, it's no problem. I mean, 2 stations can have same MAC address, no problem. So bypassing the authorization is quite simple. You find someone who is authorized, and then you will use his MAC address. To avoid any conflict, you will use a different IP. So basically, when you receive traffic with the other guy's IP, your IP stack just drop the packet silently, and it does the same. So you both can surf with no problem. So it works very well. I tried it at the airport before coming here. And it's very, very usual authorization tracking system. So the other one is I will track the IP, only the IP. It's quite unusual. I've seen it a couple of times. It's a bit more complicated to bypass. In fact, you have to spoof the IP. And if you want to allow the guy to serve, because you still have the ability to, take over his authorization. So you disconnect him and take his place, but it's no fun. So you have to spoof the IP. So on a LAN, to spoof an IP, you just have to hardcache poison the gateway, just to grab all the traffic destined to the IP, and then you will sort your traffic to his traffic and send it, all the things to him. So that's quite simple, and it works anytime. The last system is MAC address plus IP address tracking. So basically, they rely on the DHCP server leases. So they get the IP, they get the MAC address, and they check both of them. So people are tending to think that is the smartest way to do it, and that people cannot break it, but it's not the case. So previous technique won't help you because you have MAC address checking, so you have to do more than IP spoofing. So you will do the same as before, but instead of just sending packets with your own MAC, you will spoof the other MAC address. So it can be surprising like this, but it works very well. It works very well because on most of IP stack, IP level and MAC level are completely disconnected. There's no verification on them. So I can receive an IP packet with a given MAC address and send packet to the same IP with another MAC address. There's no problem. So that's the thing. So this technique works quite well. So then you have, misconfiguration-based tricks. So it can be quite amusing, quite funny to just scan the gateway. So on some networks, we could find an HTTP proxy completely open on a port of a gateway. So you just use it and you go. You have, most of the gateways are Linux-based. So we have this nifty, the magic rule, established related traffic accepted. So it means that once you have been able to send traffic outside, to establish the connection, then this connection will be authorized until you just close it, even if your authorization has expired. So if you have a 5 minutes card, then you can use it just as long as you want until you close your latest connection. So just open SSL VPN or stuff, and you can surf as long as you want. Another thing is administration network. So all these networks, APs and stuff are administrated. And most of the time, the administration network is just the same as the network you use, but they just use a different IP range. But you can just access points, configuration interface. You can try to route the box that is administrating this stuff, and or just leave the network to grab a couple of login passwords. It's very effective. In fact, you just have to generate a denial of service and just wait for the administrator to try to fix things. So there is quite many misconfiguration like this, but they tend to be more and more unusual. because people are trying to make things better. So the funny thing about Wi-Fi commercial stuff is people seem reluctant to go to WPA and .1x stuff. But .1x stuff relies on radius server. Radius server are typically used for billing and accounting and things like this. I mean, they have the best tool to do this, but they seem to be reluctant to use it. So, well, we'll see. And then the last thing, attacking stations. So when you're on a hotspot or an open network, you can just try to attack other stations. So what can you do? So you can do basic LAN attacks, so hard cache poisoning, rogue DHCPs, DNS spoofing or DNS cache poisoning for Windows workstation, where the DNS cache. You can try to play with their traffic, interception, tampering, and stuff. And you can just try to scan them and see if there are vulnerabilities and then exploit them directly. So manufacturers have figured out that there are some risks. So they try to, they put what they call solution to the problem is configure the AP to refuse two associated stations to communicate directly between them. So I explained earlier that when two stations want to communicate each other, then the IP, the access point, has to duplicate the frame with changing a flag. So with this kind of protection, the access point don't do it. So you just can't talk to other stations. It's a bit like private VLAN stuff. So you're on the same network, but you can't communicate with each other. But the thing is, a Wi-Fi network is wide open. So, well, I will be back on this. So traffic tampering is something which is very easy to do. So if people were at DEF CON, I think it was last year or 2 years ago, there was that two guys who were playing with Wi-Fi traffic. So basically what they did is they listened to Wi-Fi traffic and they tried to catch HTTP requests. And every time they catch an HTTP request, they give an answer. So basically, what you had is some images replacement, or you get another pages. So in this case, it was a blinking hello DEF CON you got, or with a nifty JPEG of one. That's it. I see people who are knowing the trick. So that was quite funny, but now think of this with a more malicious perspective. We know that browsers are very vulnerable, especially the Microsoft Internet Explorer, that has still code execution on it. So basically, anytime someone is doing an HTTP request, you can just inject whatever code you want. So a web page with a JavaScript, with ActiveX, with an image, with a malicious image, with this flow on image parsing, or things like this. So you can just hold a Wi-Fi station just listening what they do. So that's quite nifty. So communication injection. So the thing is, sometimes you have this protection. So Cisco called this PSPF. So it's well, I don't remember what it means, but it's station-to-station traffic prevention. So basically, because traffic is just sent over the air, you can just grab it and then inject what you want to establish the communication. So the thing is, if I want to talk to a station, I will do it myself without using the access point. So this allows to bypass protection. This allows you to communicate to station within reach, even if the access point is too far to get associated to it. And it allows you to communicate with station if the access point refuses you to get associated. No, for example, if you have a MAC address filtering or something like this. So proof of concept for this is a tool I made with Wi-Fi type, so it will be online in a few hours. So it's proof of concept. So I had an argument with a guy from Cisco pre-sale. So I just wanted to write it to show him he was wrong. So it's written in Python. It relies on SCAPI I mentioned before. So basically, it's a tool that allows you to communicate with a station on a wireless network without the access point authorization. So it relies on a tune type device, so you have no stack to implement, and uses Wi-Fi traffic injection. So it works like this. So it just needs network and then push the frames after I remove .11 headers and push the frames to the tune type device. And to send frames, I do the inverse. I take the Ethernet frame, add .11 headers, and send them on the wire with the from DS flag set. So when I send the frame, the station accepts it. So I'll try to make a demo. So I hope Murphy is not looking at me. Okay. Okay, so syntax of the tool is quite simple because the So the only thing you need, in fact, is the AP you want to spoof MAC address. So I put a bit bigger because whoops. Okay, easier to see. Okay, so it works in clear text. It can work with WebSet. So knowing the key, we can just inject web frames. That's it. So the things I will do is, so I have only one interface set. It's ETH1, so ETH1 is a Prism 54 interface. It's in monito mode. Okay, so I'm not associated to, I have no hub interface associated to the network. So what I will do is try to communicate with REcon Monet associated stations. So I give the BSSID and then the interface I will use. Okay. So the next thing is configure the interface, the tune tap interface. So give it an IP on the network, and then finger crossed, we'll try to establish some communication. So the basic, the easy way to do this is doing a ping scan, and so we'll see if we can ping someone or get ARP request answered. Okay, so as you can see, my ARP requests, some of them have been answered, and I can just detect some computers up. So I won't go further on the demo because it's not that interesting. The thing that is important to me about this tool is you can just communicate with any station you want, providing it's in your it's reachable with your Wi-Fi adapter. So that's it. Okay. So it's not online yet, but you will be able to download it afterward. And as you will see, it's a script. It's about 400 lines of code, just like this, and about a third of this is argument parsing. So, suppose you have a hotspot, commercial hotspot with PSPF protection. So the thing is, your only solution to get an authorization is to eject the guy and take its place, because you cannot send him the traffic back. But using this tool, you are able to do this. So that's more ethical, you know. So the guy won't complain and things like this, and he doesn't lose money. So that's it. So okay, it's nearly finished. So now we'll see what we have now to protect Wi-Fi networks. So these are the latest standards. So WPA that was published in 2003, and .11i, which was published last year, and WPA2. So WPA is an extract, so it's a recommendation, not a standard. So the Wi-Fi Alliance, which is a consortium of Wi-Fi stuff manufacturers, have made this group, and they give recommendations. So they saw that web was completely fucked, and so they said, well, we have to do something. So because they are also involved in the IEE, they try to extract some transitional work for them to propose something better. So this something better is WPA. So WPA just replace everything. So it's changing the authentication scheme. So the new authentication scheme can be based on pre-shared key or .1x authentication. So it's pretty strong, and the main thing of this is the key that will be used for ciphering will be different at each association. So that's the main point. So they have a new key generation and scheduling scheme, which is pretty strong. We can say this. So the main thing is key renewal for every association. So on the same network, every client has a different key. And a new integrity check, so which is SHA-1 based. So it's not so strong, but it's okay for a wireless network within the given time of association. So it's pretty solid, and it can prevent injection replay. Because when you calculate the MIC, the NIC, you will introduce a sequence number. So each frame is sequenced. So if you try to inject, you will have sequencing problems. If you try to replay, then your frames will be out of sequence. .11i, so .11i is a standard, a real one, was published last year. And WPA2 is a recommendation from the Wi-Fi Alliance based on some of .11i aspects. So you have the major things, but not the whole thing. But nowadays, on the market, there's no real .1i complete implementation. So we have to start with WPA2, but it's quite okay. So the authentication is .1x. Ciphering uses AES. So they finally realized that to cipher packets, frames, it would be better to use block cipher than stream cipher. So 4 years to figure this out. And then the integrity check is using a MIC based on AES. So now we're back to this solution is solid. It's been studied, it works quite well, and it provides good solution to Wi-Fi network insecurity. So you have strong mechanism, but you have some flaws that are left. On WPA, you have mathematician who has published an attack that will allow to accelerate brute force attack against a session key. So the session key is called PTK, it's a temporal key. So the force of the attack is no more 128 bits, it's 105. So it's reduced, but it's still out of reach for now. And then you have this pre-shared key brute force. So that's quite classical. Anytime you have some pre-shared key authentication, you will have people trying to brute force it. But the thing is, if you have a WPA network with pre-shared key, so you have the authentication, and then you have the key calculation, so clients have different key. So if you get the PS key and you are able to sniff all the traffic, you will be able to grab all the key used by all the clients just from the authentication. So that's quite important. So for WPA PS key, you have to use at least 20 characters, at least. But I mean, the most easy thing is you take two files, you take the MD5 sub, you take them both, you have 256 bits string, and you use it as a key. That's okay. And then you have attacks on countermeasures. So as I told you before, you have mechanism to try to spot replays and traffic injection. Basically, when a replay or traffic injection attack is detected, the association is broken. So the AP tells the client, you have to reassociate again. So reassociate, re-authenticate, and then you will be given another key. So the attack is quite simple. You just inject crap over the network, and then all the client will have to re-authenticate all the time. So that's very easy to do. And the last, all wireless networks are prone to physical attacks. So Wi-Fi networks, you have two physical attacks that are very effective, and you just can't prevent them. So the first one is jamming. So you take some kind of RF emitter, you set them on the good channel, and they will broadcast just crap to the network, and no one will be able to communicate anymore. The last one is bandwidth reservation. So using a modified firmware, you are able to bypass layer 1 restriction of the standard. as say, you will be able to emit when you are usually not able to do this. And the consequences, when stations are listening to the traffic and waiting for a time window to emit, they just won't find it. So no one is no more able to communicate. So that's for example the observation. So you just can't prevent this kind of attack, but it's due to the fact it's wireless network. You can do it on GSM, you can do it on WiMAX, and any wireless network. So as a conclusion, Wi-Fi environment is very insecure because it's wireless. And it's very tough to secure. It's very tough to bring security to this kind of environment. And we can't just work with amateur style protection. I mean, I don't know what these guys have in their mind when they produce web. Web is well. So the conclusion is don't use web anymore. Any kind of it. I mean, even with 256 keys, it's useless. Don't use open network for public access. You have the risk of being used, and you make people take risks when associated to your network, and that's bad. And the last thing is, now we get WPA, we get WPA2. All operating system on the market supports them. So for Unix things, you have WPA supplicant, like especially on Linux, which supports most of the drivers. It works on PSD2, so there's not much reason left to not to use WPA, and WPA2 is possible. And that's it. So if you have questions? Yeah.
Yeah, well, I see you speaking of web and the new WPA2, that from my room on the 5th floor here, there are 8 access points, and 4 of them are not even web protected. Do you think it's going to change with WPA and WPA2? Or do you think we'll still find more than half of them
There's a funny story about this. For Concept West, I'm involved in a French IT security magazine, and so we launched a contest, so write an article and win a trip to Concept West. And the winner is a guy who went to an area in Paris which is called La Défense. La Défense is a place where you have most of the major companies in France. And so he took his laptop and just wild drive around. So 60% of access points he found were just open. So I mean, it's a thing of people are not learning anything from the past, and especially computing. You can provide them tools; they will just stuck to what. I mean, it works like this. Why change? So you have this end user problem. And another problem is manufacturers are reluctant to implement this. So in France nowadays you have some ISPs that provide you get your DSL access with a box, and this box is doing a router, wireless access point, you got TV, phone, and this, and this only provides web for protection. So even if the end user wants to implement WPA, he can't. So he has to use his own access point. So I mean, we'll still have open networks for quite a long time. But I mean, that's it. I'm not very optimistic about the change. So I've seen some commercial hotspots who have switched to WPA. So now you can authenticate through WPA, but it's very rare. And you still have the classical web portal authentication, so you're still able to hijack authorization and serve for free.
What protection does using a VPN offer you?
Basically, well, it depends on the way it's implemented and configured. I mean, if you use a VPN with a pre-shared key, then you will have kind of brute force, PSK brute force attack. But I would say that a well-configured VPN is more secure than things like WPA or WPA2. But you have to think that on this mechanism you can have certificate-based authentication, you can have strong ciphering, so AES, and you have a pretty good integrity check. So it's a choice you have to make, but personally, I rather use something like WPA2 than use a VPN over an open network, because it will be more easy to try to trick my VPN stuff than the WPA2, playing with ARP request and DNS stuff. As an example, I was conducting a pen test on a company, and I figured out that their stations were configured with VPN access, but still using the network DNS server. So what's the point of VPN? So that's a choice, but you can do both of them if you want.
Yeah, both would be better.
Yeah. It's okay. And there was a question in the back.
He answered the same question I was going to.
Okay. Another question?
I was going to say, it's not so much a question as a comment. This is a problem I run into all the time. I constantly have requests from people to open up completely open wireless networks so that when so-and-so from the office in California comes to visit the office in Canada where I'm in, he can just turn on his Wi-Fi enabled laptop and surf without any need to put even a web key in there. And it seems to be almost more social engineering than anything else. We're trying to convince people this isn't a good idea to do. The attitude we're getting from random user is, this is fine, we do it everywhere else, it's so convenient, I want to just walk in and be able to surf. I find we're fighting that more than anything else. It's just people have gotten used to the fact that there's open Wi-Fi spots everywhere and they want to walk into it. I'm more concerned with educating people than having the most current encryption.
Yeah, but it's also a question of conveniency. As an example, if you use Windows 2000 with EAP authentication, so .1x, so when you are accessing the network, you will have a pop-up with login password. So it's simple. You access the network, you have the pop-up, you fill in the field, and you're done. With XP is fun like this. You have a small icon in the tray bar, which is represent your Wi-Fi interface. And when you will have to authenticate, you will have just a bubble say, click there to authenticate. So you have to click on the icon, and then the bubble will show. This is very inconvenient. And the thing is, if you want to hide the icon in the tray bar, you can do it. It's the default setting. Then you cannot click on it, meaning you cannot authenticate to the network. So, it's also a thing of making things easy for people. It's more easy to convince people to use security stuff if they are convenient. That is my point of view. Last question? Okay, so thank you for listening.